Hi, and welcome to the Unit 1.4 Foundations of Chemistry video. In this video, we're going to talk about how we quantify matter and analyze matter. So I want to begin with a brief outline. That's because it's been a while since you've seen one of these videos. We're going to start by reviewing mole maps, which is a key skill or strategy that we use in doing stoichiometry problems. We're going to define what stoichiometry is, and then we're going to do some examples. We're going to focus mainly on analyzing and planning, and not really so much on solving. So just a brief review about a mole map. A mole map is a very nice strategic tool that you can utilize to help you sort of map out ways to convert from one quantity to another. And you'll notice that the central quantity here is the mole. So for example, for a given substance, if you are given the mass of that substance and you wanted to find the pressure, you could utilize this mole map to sort of help you map out how you would do that. And along these arrows here are equations that are used to help you go from one quantity to the next. So let's just look at a quick example problem just to review what we've seen before. In this example problem, we're asked how many water molecules are there in 7 grams of water. So how do we use a mole map for this? We start by looking at what we're given, which is the 7 grams of water, and grams is a unit for mass. So we're starting over here on the mole map, our mass of water. And what we're trying to find the number of water particles or molecules. So we're trying to go over here. And we know that we'll have to go through moles, so let's go ahead and map out our plan. So we start with our mass, go to moles, and then for moles we can go to number of particles. That's the route that we've mapped out. Now solving this, we can choose either use a plug and chug method or dimensional analysis method. And we'll look at that later. Let's just give you an opportunity now to see if you can map out a plan. In this CFU, you're asked to make 4 liters of a 5.0 molar sodium chloride solution. How many grams of NaCl do I need? So just to be clear what this information is, 4 liters represents the volume, and of 0.5 molar is the units for molarity, which measures the concentration. So how concentrated is that solution? So you have the concentration of the solution and the volume of the solution. Use the information in the mole map now to see if you can map out a plan for yourself. When you press play again, the answer will be revealed. Great, so in this problem, you are given the volume and the concentration, and so you're starting over here, and you need to find the mass, so you want to go from the molarity information to the moles and then to the mass. Great, let's try another CFU. I'm going to do the same thing here. So in this case, it's a 5-liter helium tank at 1 atmosphere and 300 Kelvin, which is the temperature. And then you are asked to figure out how many helium atoms it contains. Pause the video now, and when you press play again, the answer will be revealed. Okay, so here's the answer. You're given the volume, the pressure, the temperature. So you're starting over here in the mole map. And you need to find the number of particles. So you want to go down to over here, and your plan will look something like this, starting with the PVT information. You set to find moles, and then from there find the number of helium atoms. Okay, now in terms of solving, we're not going to look into it, but I just wanted to point out again that there are 2 methods, plug and chug and dimensional analysis. That's not covered in this video. We'll do more practice like that in class. But going back to what you covered before in the 1.3 video, you saw how the plug and chug method basically involved plugging in your given variables into the equations that are along the mole maps, and then you do that sort of in a stepwise fashion until you get your final answer. So this was what it looks like for this equation. If you want, you can pause and then look through and sort of analyze what was done here. Whereas dimensional analysis, you're focusing on the units and trying to figure out how to cancel out units. So you start with the information you're given, the 7 grams. You use the relationship or this conversion factor here to convert from grams to moles. And then you use this conversion factor to convert from moles to number of particles. And these 2 conversion factors actually are found in the equations on the mole map. So this represents the molar mass. and this represents this equation that we have used before. Either way, after you cancel out your units, you get the same answer. Okay, so now let's go into stoichiometry because that's really what the heart of this video is about. What is stoichiometry? Stoichiometry problems involve when you're given the amount of something and you're going to use mole ratios to find the amount of something else. The amounts you can be given could be something like your moles, or maybe your mass, number of particles, volumes, concentrations. And this is where mole maps are helpful because the amount that you're given and the amount that you're asked to find could be different. And so you can utilize the mole map to help guide you into what you're doing. In terms of the mole ratios can be found in chemical formulas and also balanced equations. So let's take a look at chemical formulas first. If you have something like potassium nitrate, KNO3, you can tell from the subscripts that the ratio of nitrogen to oxygen atoms is 1 to 3. You can also tell from the subscript that if for every mole of KNO3 you would only have 1 nitrogen atom. So every mole of this entire compound, you would only have 1 nitrogen atom. So that's a 1-to-1 ratio. You can also find ratios, molar ratios in balanced chemical equations, and those in this case will come from the coefficients. So here we have a double displacement reaction, which is potassium hydroxide reacting with lead nitrate. And we can tell from the coefficients that there's a 2-to-1 ratio of potassium hydroxide to lead nitrate. Okay, so before we dive into a full-on stoichiometry problem where we have to use the mole maps, let's look at a simpler one where we're just using mole ratios. So we're going to start with this first CFU. How many moles of hydrogen atoms are there in 6 moles of H2O? You're going to pause the video now. Remember, in this case, you're going to use the subscripts. And when you press play, you're going to try this on your own. When you press play, the answer will be revealed. Okay, so we're just going to do analyze, plan, solve. First, we're given 6 moles of H2O. We want to find moles of hydrogen atoms. So in this case, we know that the ratio is for 1 mole of H2O, there are 2 hydrogen atoms, 2 moles of hydrogen atoms. And to solve, we can use either method. I'm going to use dimensional analysis, so I'm starting off with my given, which is 6 moles of H2O. I'm going to use, this molar ratio becomes my conversion factor. I can use it to convert from moles of H2O to moles of hydrogen. Because I want to cancel out H2O, I make sure my H2O and the conversion factor is on the opposite side. If you're curious where this conversion factor comes from, it comes from this equation. I just turned it into a fraction. And then my moles of H2O cancels out, leaving me with moles of H, which tells me 12 moles. This is something you could probably solve mentally, but it's good to see dimensional analysis. Okay, we're going to look at now another example where this time we actually have to use the mole map. So we're asked in this case, how many hydrogen atoms are there in 32 grams of water? And this is where the mole map is helpful. Look at the information that we're given here. We're given 32 grams of H2O, and we're trying to find the moles of hydrogen atoms. So we're given the amount of one substance, and we're trying to find the amount of another substance. So let's start here at the mole map of water, and then we're going to use the conversion factor, which comes from our molar ratios, to get to the mole map of hydrogen atoms. So we're starting here, 32 grams of water. This is the water mole map. And then we can use the right equation to go from mass of water to moles of water. Once we have the moles of water, we can use the molar ratio. There's a 1 to 2 molar ratio for water to hydrogen atoms to convert from moles of water to moles of hydrogen atoms. Once we are over here with the moles of hydrogen atoms, now we can get to the particles of hydrogen atoms. So our mapping looks like this: mass of water to moles of water, sorry about that, to moles of hydrogen atoms, to number of hydrogen atoms. All right, we're going to try the CFU. You're going to map out a plan to answer the question, how many grams of water would contain 1.2 times 10 to the 24 hydrogen atoms? It may be helpful to have the mole map. When you are ready, press play and the answer will be revealed. All right, so this is what your work should look like. In this case, you are asked to find the grams of water. So we're actually trying to go over here, but we're starting over here with the number of hydrogen atoms. So we go from number of hydrogen atoms to moles of hydrogen atoms, use the molar ratio to go to moles of water, and then from moles of water, we can go to the mass of water. Okay, we're going to do stoichiometry again, but this time instead of using mole ratio from a chemical formula, we're going to look at balanced chemical equations. And again, in that case, you look at the coefficients. So let's try this CFU. How many moles of NH3 can you make from 9 moles of H2, assuming the reaction goes to completion? And this is the balanced chemical equation. This is not a mole map problem necessarily. You don't need to use a mole map here. You're just going to use your understanding of ratios to go from, if you're given 9 moles of H2, how many moles of NH3 you can make. Pause the video, and when you press play again, the answer will be revealed. Okay, so analyzing. You're given 9 moles of H2. You want to find the moles of NH3. Your plan is to use the ratio that there are 3 moles, according to the coefficients, to 3 moles of H2 to 2 moles of NH3. And solving it, you can use either of those 3 methods. Let's use the mental analysis, starting with 9 moles of H2. I want to get rid of the H2, so I put in my conversion factor, which comes from these molar ratios, H2 in the bottom, NH3 on the top, along with their coefficients. Those will cross out, and then I get the moles of NH3. So that's what that would look like. Okay, now how would a mole map be helpful? And if you're not given moles and asked to find moles, that's when a mole map is helpful. So like in this problem where you ask how many grams of N2 do you need to react with 3 liters of H2, and they're giving you all this other information here. So we're going to use a mole map for this. We're given the volume, the pressure, and the temperature of H2. And so we're going to start over here, the PVT of H2. And then we can use that to find the moles of H2. Once we have that, we can use the molar ratios to go from moles of H2 to moles of NH3. And then once we have that, once we have the moles of NH3, we can then, or I'm sorry, in this case, this should actually say N2. So you want to make that correction on your paper. So this should say moles of N2 here. Once you have the moles of N2, then you want to go to the mass of N2. So we got some changes to make here. Make sure this says N2. And you also want to change the coefficient here to 1. Let me do that now and then I'll come back. Okay, sorry for that confusion there. So I just made the corrections. So again, we're starting off with the pressure, volume, and temperature of H2. We use that to get to moles of H2. Then use the conversion factor, which comes from the molar ratio, 3 moles of H2 to 1 moles of N2. To go to now the moles of N2. Once we have the moles of N2, we can find the mass of N2. All right, you're going to try something similar out using this mole map. In this case, it's how many grams of NH3 can you make from 12 grams of H2. So maybe create your own mole map. You don't have to write everything out on the mole map, but just the things that you're given. When you press play again, the answer will be revealed. Okay, so we're starting off with H2. You have mass of H2, and then from there you want to get to mass of NH3. So we're starting here, mass of H2. We go to moles of H2. Use the mole ratios to go from moles of H2 to moles of NH3. Once we have the moles of NH3, we can go now to the mass of NH3. Alright, so that's it for this video. In class, we're going to spend more time practicing on mapping things out, but we're going to spend a lot of time focusing on how to solve it. This is helpful not only for this unit, but throughout AP Chemistry and chemistry for the rest of your life, because stoichiometry is the one skill that any wet lab chemist will use, and it's super duper helpful. Anyway, I hope you found this video helpful. Take care and have a quality day.